Today is September 2025. First, memory property, which is you don't care about it will be same. So even you waited for bus 10 minutes, or you right now waiting for the bus, maybe there could be no difference when bus will come, then it will be memory's property. Our life is different. Like when you get aged, uh, the probability is different. You will die within 1 year. If you're 10, it will be very low, but if you're 90, probably the probability will be super high. And okay, for today, or maybe random variable X can be follow Poisson distribution or exponential distribution. I want to give an example with exponential distribution. In exponential distribution case, PDF will be lambda multiplied by e to the minus lambda x, and CDF will be 1 minus e to the minus lambda x. Then from PDF to CDF, we should calculate by from integral minus infinity to x and integral the PDF. In this case, random variable x is non-negative, so it will be from 0 to x. And if when you calculate EX, and EX scale, everything is recorded moment. And if you use moment generating function such as EXT, we can actually calculate the EX and EX so on by the EX into the XT or something. Then we can calculate this by differentiate it. So right now, into the expectation of X will be X fx because it is continuous function. Because it's continuous function, then fx we should put the pdx here. So then we can calculate it by integral. What was it? Let's say this is u and this is v prime. Then we can calculate it by integral of uv minus integral of u prime v. So then we can get 1 over lambda. And it's just, I think professor just gave an analogy like infinite by epsilon. Like, let's say, real number point has no possibility, but probability, but rate is probability. So let's say it's uniform random function. So from 2 to 4, it will be 2 multiplied by 1 over 2. In this case, we kind of learn it in calculus cliff. Infinite multiplied by epsilon is k. This is like many epsilon by infinite is k. Or infinite. Yeah. I think this is just analogy. So also exponential distribution has memory property. So if you put probability using this probability px is smaller or same than x. This is the just definition of CDF, right? So if you use it, then 1 minus e to the minus lambda x is CDF. So px is bigger than t plus s is. You can get it easily by 1 minus CDF. Then if you calculate it at this one, and this is same with t is bigger than x over s, so we can easily notice it. And today what we learned is also the measurement different by part and first order approximation. And if you do approximation, oh my God. If you do approximation, what you can do is by limit, by using the definition of limit, you can write down the transcendental function with polynomial function. That would be important thing. Right now, stop. my computer is stopped right now. Mm, the computer is stopped. My computer is stopped.
그림이 아니라 DM
Sorry,
있잖아.
I'm still recording it. I'm sorry. Yeah, so yeah, you can like think about why computer can throw sine function but not my hand. And we can talk about when x is continuous random variable and there's given PDF, then you can talk about the expectation x. So fx should be given a real number built in real number interval. That's what we talked about. And there are some examples of and anti-examples of Memoryless property. And if you compare the Poisson distribution and normal distribution, there's very big difference in standard deviation. We can use it in coffee shop or real scenario cases like coffee shop. Even you wait for 10 more minutes, there would be no people more come in general. Thank you.